What? Go.
Tuberculosis is a disease caused by Mycobacterium tuberculosis. This disease is spread through close quarters contact like coughing. And symptoms include coughing up blood, bad cough for over 3 weeks, weakness or fatigue, and no appetite, chills, or weight loss. It is normally treated with antibiotics, but in some cases there's a mutation in the M. tuberculosis where the current antibiotics cannot consume the mutated M. tuberculosis, which will lead to the research of different methods to treat the disease. This is Mycobacterium tuberculosis. The cell wall is represented by the outer rubber, and this is represents the peptidoglycan layer and the lipid bilayer. And on the inside we have candies and air, which is going to represent the cytoplasm and the organelles. Now if you can break this wall, second cut. As we break the cell wall, that's very tough to do, the cell becomes unstable and the wall breaks, exposing the cytoplasm and the organelles. This allows for the cell to be either totally annihilated or just eaten by a white blood cell or other things. And it is very delicious.
The D-alanine chains are made by a protein called DDL, D-alanine ligase. To understand how to be able to break the D-alanine, we first have to understand the mechanism on how the D-alanine is made. Although the exact mechanism isn't completely known, it is known that the protein is a dimer, meaning that one thing happens on one side the same as the other. So I'm just going to simplify it and just talk about what happens on one side. Now first, ATP and D-alanine will bind to the molecule. Notice that I represented the model by showing a diamond active site and a triangular connection on the D-alanine to represent that this alanine cannot bind unless there is a conformational change in the protein which allows it to bind. This allows for the D-alanines to connect together, forming this D-alanine chain. To stop the production of the D-alanine chains, we have to figure out a way to inhibit this molecule. To inhibit the production of D-alanine, a molecule called DCS is used. This DCS can bind to the active site where ATP originally binded. Notice when it binds to the active site, it blocks the active sites of D-alanine so that they cannot bind to the molecule. Notice that one active site is completely hidden, whereas the other is partially there. In the research article, they talked about how one of these sites was inhibited a lot more than another one, which I represented in the model by having a little bit show through. So, since the D-alanines cannot bind to the DDL, they cannot be joined together, and the D-alanine chains on the cell wall will not be formed. Without these chains, the bacterial cell will die, and this is a method that we could use to treat tuberculosis by using this drug called DCS, which could kill the cell wall of the M. tuberculosis cells and therefore treat M. tuberculosis.